when the light rays incident on a plane mirror, this is how the reflection occurs, right? This is how the reflection occurs. You can draw the diagram either by looking at the diagram on the board or the one in the textbook. When the light rays are incident, so this is how we draw the plane mirror. Again, this is nothing new. Previous grades you have done it. Then this is the light ray which is incident on a plane mirror perpendicularly. So it will get reflected along the same path. It will get reflected along the same path. So this is for the sorry, first box. And for the second box, when the light rays incident at an angle. So this is the perpendicular line of the normal, right? So this is also coming along the normal. So therefore we can't draw the normal here. Here, this is the normal. And this is the incident ray. So we can mark it as I, angle of incidence. And this is the reflected ray. So the angle is R. This is the point of incidence. So this is for the second box, and you have to name the parts, right? So this is incident ray. This is reflected ray. This is the normal. So I is the angle of incidence, angle of reflection, point of incidence. So these are the parts where you can name. So if you don't like to name like this, you can put some letters, and I have provided dotted lines at the bottom. You can fill it with like this. Here. So they have put A, B, C, D. Or if you can, if you like, you can do it that way, or you can do it this way, because this is straightforward. You can see things. You don't have to refer to the letters. So referring to the letters, additional effort. Okay, hurry up and draw. Okay, after that, we'll continue. Then below are the laws of reflection. Then again, the laws of reflection you have studied earlier. There are two laws of reflection. The first law, the incident ray and the reflected ray and the normal at the point of incidence lie on the same plane. Second law, the angle of incidence is equal to the angle of reflection. And according to that, incident ray, reflected ray, and the normal at the point of incidence lie on the same plane. Now, all this information is located in the plane called the whiteboard, right? So the information is there. Incident ray, reflected ray, and the normal, all the information are there on the plane of the whiteboard. And again, they are telling as the second law, angle of incidence is equal to the angle of reflection. These are the two laws. I think in grade 7, 8, 9, we have done it. May not be remembered, right? So you can write the two laws there. You can write the two laws in the boxes. Hurry up. You can start now. Write in the two laws. Sorry, you have written the laws. Laws are okay. Then we are going to draw a ray diagram. Right? We are going to draw a ray diagram to represent how the image of a certain object is formed by a plane mirror. So in this case, you can draw it. Now look at the way I draw it. So this is my mirror. Then I draw a perpendicular line like that is going to help. Okay. Then what I do, I can mark my image. Imagine it is letter B. Right? It is letter B. Then I measure the distance If you have a ruler, so you can measure it easily. Since I don't have a ruler, I have to find some alternative method. So this is the place where the image will be. So there is additional thing that I do in order to increase the accuracy, because I don't have facilities to measure the angle. So therefore, I straight away mark the place where the image will be formed. Okay. Then I take two rays coming from the whatever the two rays. I took the two rays. Then keep the ruler here and here, merge it with a dotted line. Merge it with a dotted line. Without lifting the ruler, extend the line. So this will be a straight line. This will be a straight line. Then again, same thing you have to perform with this point. Again, dotted line, merge in the two locations. Again, without lifting the ruler, extend the line. Right. And this is where the eye will be. And you can see the image. These are the two normals which are drawn to the point of incidence, N1 and N2. And these angles equal. These are equal. So this is how we obtain the image of a object, image of an object which is kept in front of a plane mirror. And again, there are certain properties for the image also. Now these are the properties. The first one, the image size will be equal to the size of the object. We call it same size. Then it is upright. So when you are standing in front of the mirror like this is the head, this is the legs, then it is not going to be inverted. The image is not going to be inverted upside down when then end up, upright, or else both words are there, upright or the erect. Then what else? Now this is called lateral inversion. Now you can see the sides are interchanged. Now when you touch your right ear, right, in front of a mirror, the image will touch its left ear. So that means your left and right sides are interchanged. That is called laterally inverted. Laterally inverted. Then what about this one? This is called the object distance, the distance between the object and the mirror. It is called the object distance, and this is called the image distance. So both are equal. Then finally, we say the image formed within the mirror cannot be obtained onto a screen. So therefore, those kind of images are called virtual images. Virtual. They can only be seen, but they cannot be obtained onto a screen since the image is formed within the mirror. So you can't touch it. You can't keep a screen there in order to take it onto a screen. Now, when we think of a multimedia projector, by a multimedia projector, we are getting a real image. That's why we could put it onto a screen or a wall. But here, this image, we can't do like that. It is going to be a virtual. It's not a real image. So these are the properties. You can write that on that dotted line. You can start drawing and you can write the properties of the image on that set of dotted lines. So if you have done it, I am talking about the image, not the device. uh, I think you may have done it, finished it. So anybody who's still doing, I think you have done it. So we'll continue. Now that this is the reason behind the word of the ambulance in written or the printed in the other way around, from last letter to the first step. The reason when the driver in front of the ambulance looks through the rear view mirror, when he hear the sound of the ambulance, the incorrectly written image will be laterally inverted and the correct image will be seen by the driver. So it is easy to identify there's an ambulance coming behind. So that's the reason behind that. Okay. Then we are talking about curved or the spherical mirrors. Now, when it comes to curved mirrors, right? When it comes to curved mirrors, there are two basic types. When it comes to curved mirrors, there are two basic types. The first type of mirror, right, taken from a sphere, section of a sphere. When a section of a sphere is taken as the mirror, it is called the spherical mirrors. Spherical mirrors. Then there was another type. When we take a section from a parabola, we call it the parabolic mirrors. So here in this syllabus, we are not going to talk about this because in the previous syllabus it was there. Now I can give you an example. Parabolic mirrors are used as lamp reflectors. Now the headlamp of a vehicle, if the bulb placed here, it is capable of giving you a parallel beam of light, right? Parallel beam of light. So that's the main purpose of it. But the same thing cannot be done here. Now here, when you keep the light here, it will kind of not getting the parallel beam. So therefore, as the parallel beam, this is used unless it is a LED bulb. Normal traditional bulbs, this is the type of mirror used for to obtain a parallel beam. Okay, just forget about this one. So what I wanted to tell you is now there are types like. Okay, now we are going to talk about the spherical mirrors. Mirrors which with curved reflecting surfaces are known as curved mirrors. If the curved surface is a part of a sphere, the mirror is known as a spherical mirror. So we can write something like this. Concave mirror. So this will come to that box. Concave mirror. And you can draw a diagram of the concave mirror. So this is how it appears. But the reflection will be done from inside. Reflection will be done from inside. Reflection will be done from inside. So we can say the curved surface is, sorry, the reflector part. The reflecting surface is curved inward. Reflecting surface is curved inwards. The other type, convex mirrors. Now here, the reflecting surface is curved outwards. Right? So the light rays will be reflected from this side. Okay, you can fill your blanks with this information. Okay. Below diagram shows that spherical mirrors are part of hypothetical mirrors. Hypothetical කියන්නේ මනක් කල්පිතක. මනක් කල්පිත ගෝලයක් ස්පියර් එකකින් කපාගත්ත කෑලි කියලා කියනවා මේ spherical mirrors. මේ බලන්න. Look at the diagram. So the dotted line representing the hypothetical sphere and the section cut from it. Concave surface, this one, convex surface. And there are certain things were named center of curvature, that is the center of the sphere, and the line which is merging the center of curvature and the center of the mirror is called the principal axis, and the concave surface, and the place where the principal axis touches the mirror is called the pole. And again, the same information is there for the convex mirrors. Same information is there for the convex mirrors. So what you can do is you can draw